Memorial Day weekend marks the undisputed starting line of the American summer. It is a time for barbecues and family gatherings, signaling a massive, synchronized migration. Millions of travelers load up their cars and flood the airports, a surge of movement that pushes national infrastructure to its breaking point. Most of us believe we are in total control of this journey. We choose the best flights, map the quickest routes, and secure the perfect hotel. The reality is far more intricate. An interconnected web of artificial intelligence and predictive algorithms operates quietly beneath the surface of your holiday plans. Every mile driven and every booking confirmed feeds into a calculation designed to turn your holiday into a series of predictable, profitable logistical steps. The influence begins the moment you search for a flight or hotel. This seemingly innocent step opens the door to massive data harvesting networks. Airlines and hotels utilize dynamic pricing algorithms, highly sophisticated AI systems that analyze millions of data points in real time to determine prices. These systems analyze your browsing history, your location, and the type of device you are using. A business traveler booking from a wealthy zip code on a Mac computer will see a higher price than a student browsing for a budget trip. During the lead-up to Memorial Day, these algorithms adjust prices microsecond by microsecond to capitalize on the urgency of holiday travelers. Behavioral surveillance turns the booking process into a targeted operation, extracting the highest possible price the system believes you can bear. At the airport, the sheer volume of travelers necessitates the intervention of management algorithms to keep the gates clear and the tarmac moving. Airlines attempt to tame the holiday chaos using machine learning frameworks like gradient boosting to proactively predict flight delays before they cascade through the network. This is the landing page for a flight delay predictor. Applications like this make complex predictive models accessible to the public, allowing travelers to check the likelihood of a delay before they even arrive at the terminal. At the security checkpoint, the TSA has increasingly turned to biometric facial recognition to process the massive volume of holiday travelers. These scanners match the physical geometry of your face against government databases, evolving to identify individuals with precision, even in crowded, chaotic environments. Algorithmically, you move through the terminal as a biological unit, a predictable variable in a massive mathematical herding process. On the highway, city grids employ event-driven traffic management to handle the sudden spikes in road volume during major holidays. This is an XGBoost model's confusion matrix. Researchers use it to classify traffic volume into low, medium, and high states. But the model frequently misclassifies traffic, failing to distinguish between medium and high congestion during unpredictable human behavior. To compensate, consumer navigation apps use crowdsourced smartphone data to forcefully reroute cars in real time, often flooding quiet residential neighborhoods. Platforms use features like area busyness or surge pricing to actively manipulate where crowds gather and how they move. The algorithm rebalances the city grid in real time, effectively using thousands of individual drivers as the tools to clear its own bottlenecks. These systems work. You successfully arrive at your destination and enjoy your holiday. But that arrival comes at the cost of your location history, your biometric identity, and your behavioral profile. These algorithms prioritize systemic efficiency and corporate profit above your individual preferences or holiday joy. This is the silent digital infrastructure, constantly humming beneath the surface of every journey, perpetually waiting for the next data input. As you head out on your next trip, remember that while you may be driving the car, the algorithm is steering the entire journey.